All right, so we are coming back to those properties of exponents and properties of logarithms, and we're going to use them to now solve exponential and logarithmic equations. All right, so in the boxes here, just a recap of all those properties that we will see, so make sure you refamiliarize yourself with them. Also, being able to convert back and forth between exponential and log form, very important as we move forward because it depends on what we're solving, where we kind of get stuck in the equation. All right, so first we're going to look at some exponential and log equations. All right, so whenever you're solving either of them, you're going to isolate whichever one you have, exponential or log expression. And then if you only have one log or exponential function in the equation, you're then going to switch from exponential to log form or vice versa. All right, so remember, we got to be able to convert back and forth between log and exponential form. All right, so let's look at this first one. We have 4x minus 2 equals 7. So here's where the variable is. We're going to isolate that. So add the 2 over to the right-hand side. At this point, we have an exponential. I can't write 9 as a base of 4, so I'm going to have to convert this. Log base 4 of our answer equals the exponent, and then that would be our answer there. Okay, so log base 4 of 9 equals x. It says leave them in exact form, so I don't want decimals. I don't want to put it in my calculator. I'm just going to leave it like that. If you could simplify that, do so, but we can't. All right, moving on to b here. So again, here's where the variable is. We're going to isolate that exponential expression. So subtract the 5 over. Now, again, we're at a point where we have an exponential. Convert it to a log. So log base 2 of 21 equals x plus 3. Still got to get x by itself. So log base 2 of 21 minus 3 will be equal to x. Again, that's going to be our exact form. I can't simplify that at all, so we will leave it there. All right, again, pretty similar. Isolate the exponential, so we'll subtract 3. Now, the exponential is actually just the e to the x, so we'll have to get rid of the 4, so divide both sides by -4. That'll be 5/2. All right, and then let's convert this to a log. It's going to be log base e, so I'm going to use ln of 5 over 2 equals x. That's our exact answer. All right, now we got some log equations. So we're going to isolate the log expression. Okay, so the log base 3 of x plus 3. We got to move the 4, so subtract 4 over. Then we will have to divide by that 2. All right, we only have a single log here, so we can convert to exponential form. So it'll be 3 to the 3rd power equals x plus 3. And this is just 27 over here. If I subtract 3 from both sides, I get 24. Now with logs, we have to make sure that, because they don't have domain of all real numbers, we have to make sure that from our original equation, our domain would be where that x plus 3 is greater than 0. So x has to be greater than -3. We have to make sure that our answer falls in that domain, which it does. 24 is greater than -3. So that will be our solution. All right, for this next one, isolating the log expression, so subtract 2 over. Now we're going to convert that to exponential, so 5 to the 2nd equals 2x minus 1. 5 to the 2nd is 25, so now do some solving. We're going to add 1 over, divide by 2. We get 13, and again, we're going to go back and check that 13 falls within the domain. So back up here, 2x minus 1 is greater than 0. If we solve that, that would mean x is greater than 1/2. 13 is greater than 1/2, so that is not an extraneous solution. Okay, there will be times where we have to get rid of an answer, so we have to check on all of them. All right, so here we've got a log and it's being divided by 5. So the first thing we should do is multiply both sides by 5 to get that out of the denominator. Then we're going to convert this to exponential. Since that's ln, it's log base e, so e to the 5th. All right, so e to the 5th equals, oh, my stylus isn't working. All right, so that's equal to 2 minus x. So now if we solve, we should subtract 2 over, and then we're going to have to divide by -1. So we can get x all by itself, and it'll now be 2 minus e to the 5th. So if we check the domain here, we would get that x should be less than 2, and this will be less than 2 because it's 2 minus e to the 5th, which is going to be a positive value. So we're all good on that. All right, now solving the equations if we have multiple exponential functions. What you want to do is rewrite the equation in the form of using the same base to different exponents on each side of the equation. All right, and then you set the exponents equal, the m and the n exponents, and solve for the variable. All right, and since they're exponentials, the domain is all real numbers. We don't have to worry about extraneous solutions. So if we look at these two bases, we want to rewrite one of them, or both of them if necessary, in terms of the other one. But we want to replace it with an equivalent. So I can replace 8 with 2 to the 3rd. Those are equivalent to each other. I didn't change the value. I just changed the form of which 8 was represented. And then if you remember power to a power, we'd end up multiplying exponents, and then we're going to set these equal to each other. So I'll get 9x minus 6 on the left equals x plus 5 on the right. Solve for x. Subtract x, add 6. X is going to be 11 over 8. Again, we don't have to check for extraneous solutions because it's an exponential and the domain is all real numbers. For the middle one, so 9 and 27, the easiest base for me would be 3. 9 is 3 squared. 27 is 3 cubed. Again, I'm just replacing them both with an equivalent form, just with the same base. And then remember, we're going to multiply exponents. So this will be 2x minus 2. And over here, we'll have 3x plus 9. Nice and easy to solve at this point. Get x equals -11. And for this last one, I'm going to use a base of 2 for each of them. So 1/2 would be 2 to the -1st. 4 would be 2 squared. Remember to distribute the exponents. So -5x minus 7 equals 2x. Add the 5x over, and x equals -1. All right, so now if we have multiple log functions in our equation that we're solving. So we use log properties to simplify it. It means you need to get a single log on both sides, like this form. We already saw form 1 earlier. So here you want to get, using your rules, condense your logs on both sides to a single log with the same base, and then we would be able to set the quantities you're taking the log of equal. It's like setting your exponents equal in the above examples. All right, we will need to check for extraneous solutions because the domains of logs are restricted. All right, so we have to, on this first one, get those two natural logs into one natural log quantity. And since it's subtraction, that means they are going to be divided. And then now, since we have the natural log on both sides, we can get rid of the logs and set the two quantities equal to one another. I'm going to cross multiply because we have a proportion. So x squared plus 2x equals 4x plus 3. Since I see an x squared, it's a quadratic, so we're going to get it equal to 0. Have some fun with factoring. I'll get two solutions here, 3 and -1. And now I'm going to go back up and check my original. So checking all of these and making sure that they stay greater than 0. So for that first one, it would be x is greater than -2. For the second one, x is greater than -3/4. And then 1 over x has to stay greater than 0. So really, x just has to be greater than 0 in that case. So for all of these, we really just need to make sure that we have positives coming out of here. So -1 will not work. So that means x has to be equal to 3. When you have multiple domains for different logs in your equation, it's going to be the one that is the most restrictive. So in this case, x is greater than 0, because if it can't be negative at all, we can't have anything that would be even greater than -2, like -1 wouldn't work, okay? Because overall we have to stay greater than, so you have to go to the most restrictive of your domains. All right, so again, we have multiple logs on the left, so let's use our log properties here. Since they are being added, the two logs, we're going to multiply the quantities we're taking the log of. So I'm going to just distribute those, x squared minus x minus 6 in there. And then I have log base 3, it's a 14 on both sides. So I can get rid of log base 3 and just set x squared minus x minus 6 equal to 14. Go ahead and get it equal to 0 so that we can factor. All right, this will nicely factor into x minus 5 and x plus 4. So I get +5 and -4. Again, we're going to check for extraneous solutions. So first log, x has to be greater than -2. The second one, x has to be greater than 3. So we're going to go, that's going to trump it. So x is greater than 3, so it can't be -4. So x has to be only 5 in this case. All right, and if you're not understanding, just so we're clear, like if I have x is greater than -2, and then I have x is greater than, let me go here, 3, I have to look at those and see, you know, what is shared amongst them. All right, and that would just be when it's greater than 3. All right, now on C, since we have this quantity, that 2, that's all by itself without a log, let's get the 2 logs to one side. So I'll keep -2 here. And I will subtract log of x over to the right-hand side. I got to use properties to condense that right-hand side. So since it's 2 logs being subtracted, it'll be x minus 7 over x in there. Now, since we only have a single log, we're going to have to convert. Remember, the base of this log is 10, so I'll get 10 to the -2 equals x minus 7 over x. 10 to the -2 is really 1 over 100, because it's 1 over 10 squared. Cross multiply, I get x equals 100x minus 700. Let's do some solving. So subtract, I get -99. X equals -700, divide by -99. And x is 700 over 99. A nice, lovely answer like that. Just double checking here, sorry. X should be greater than 7, or x is greater than 0. So greater than 7 would work. 700 over 99 will be greater than 7. So that is in our domain. All right, similar on this one, we've got 2 logs on the left. So let's use our log properties. It's multiplication because those 2 logs are being added. Then since it is a single log, we're going to go 2 to the 3rd power. So 8 equals x squared minus 7x. Looks like we're going to get it equal to 0 and factor. So I get x equals 8 and x equals -1. Let's go back up here. First log, domain is x is greater than 0. Second log, x is greater than 7. So x is greater than 7 means -1 is out, but 8 is our solution. All right, now the last type, and this actually showed up on the AP last year. Question very similar to this. So solving this. So if you look at it, you're like, ooh, we got a couple e's in there. Maybe we can combine them. Yes and no, they don't have the same exponent, so they're not like terms. So I can't just make like this -3 e to some power. So what I kind of want to look at is I could rewrite this. I'm going to bring it over here so I have space. Like e to the x squared minus 4 e to the x plus 3. I'm just kind of isolating the e to the x quantity. If you look at it that way, I have something squared minus 4 times something plus 3. It's like a quadratic. So we're going to do what we call a u substitution. And I'm going to say let u equal e to the x so I can replace it in my equation. And look at that. We now have a nice little quadratic that we can factor. Solve. But we weren't solving for u, we were solving for x. That means we now replace u with e to the x. And we solve. Since it's e to the x, I'm going to go log form, which means it will be ln of 3 equals x. And on the second one, it'll be ln of 1 equals x. All right, we can't actually do that. I can say this one. This would just be 0. All right, so which both are completely acceptable. And those are the solutions. Leave them in exact form. It's an exponential, so domain is all real numbers, so there's nothing to exclude.